Hello everyone, this is Amanda Chauhan from Namchi Government College, BSc Physics 6th semester, and I have prepared a presentation with the support and guidance of our respected sir, Dr. C.P. Khateura, on the topic MOSFET. So this is the topic that I am going to talk on today, that is metal oxide semiconductor field effect transistor, or simply we can call it as MOSFET. So we will see today what is MOSFET, its application, historical background, introduction and its type. So let us begin with the history of the MOSFET. So as we know that MOSFET is a type of FET, and FET was first patented by Julius Edgar Lindenfeld in 1925 and Oscar Hill in 1934. And these patents were not for the actual FET but for the FET like devices, and this was about the concept. This is not the actual FET, but it is only the concept that was patented or that was first introduced by Julius Edgar Lindenfeld and Oscar Hill in 1925 and 1934 respectively. So, before MOSFET was discovered in 1947, William Shockley with his team tried to invent FET, but they failed in inventing FET. Instead, they discovered the first transistor, and the first FET was made after one decade of the invention of transistor. Later on, MOSFET was found to be better than JFET, and it was firstly invented by D. Kong and Martin M. Atala in 1959 at Bell Labs. So we understand that FET was discovered earlier and MOSFET that was discovered later on by D. Kong and Martin M. Atala in 1959. This was about the history of MOSFET. Now let us see the introduction part. Let us talk about MOSFET in details in this introduction. So first of all, let us understand what MOSFET is. It is a type of transistor used for amplifying or switching electronic signals in electronic devices. Basically, it works as switch. Nowadays, we see MOSFET's importance in almost every electronic devices like laptops, motherboard and many other. MOSFET is a type of FET, as I have said earlier, and is made by oxidation of silicon. MOSFET is also known as IGFET, insulated gate field effect transistor, and MOSFET, that is metal insulator semiconductor field effect transistor. And MOSFET has four terminals. They are source, which is also written as S, gate, that is written as G, drain as D, and body as B. Since body is frequently connected to the source, and it makes the MOSFET as three-terminal device like FET. And one of the advantages of MOSFET is that it requires almost no input current to control the load current when we compare with BJT, that is bipolar junction transistor. So this is a little introduction or small introduction of MOSFET. We understand that MOSFET has four terminals, that is source, gate, drain, body, and we count MOSFET as three-terminal device most of the time, since body is connected to the source and each terminal has their own functions, and the main function of gate is important in this device since this gate is a controlling terminals made out of metal and the gate voltage determines the conductivity of the device. So this is about introduction of MOSFET. Let us see the diagram. This is the diagram of MOSFET. As I have mentioned earlier, this is the source, gate, drain and body. This is the main function over this body, that over the device, that is the voltage of this gate or the gate voltage determines the conductivity of the body. So let us see the types of MOSFET. Basically, there are two types of MOSFET device. First one is depletion mode MOSFET and the second one is enhancement mode MOSFET. Let us discuss these two types of MOSFET one by one. Here we go with depletion mode MOSFET. In depletion mode MOSFET, in order to have the maximum conductance on device or in order to make the higher conductivity of the device, the voltage at gate should be 0. As I have said earlier, that gate voltage determines the conductivity of the device, and in order to have the maximum conductance on device, the voltage at gate or the gate voltage should be 0 in depletion mode MOSFET. So what we should keep in mind that is that in order to have the maximum conductance, there should be no positive or negative voltage at gate. As we apply any positive or negative voltage at the gate, then the channel conductivity or the device conductivity will decrease. And this is the diagram of depletion mode MOSFET. Now let us see what next is. So this is the second type of MOSFET, that is enhancement mode MOSFET, and it is the reverse case of depletion mode MOSFET because in order to have maximum conductivity of the device in this enhancement mode MOSFET, there should be more gate voltage. The more is the gate voltage, the more conductance is the device. So we see that it is just the opposite of depletion mode MOSFET. In order to have more conductivity or good conductivity of the device, we should apply more voltage to the gate. So here it is the or this is the diagram or simple diagram of enhancement mode MOSFET. Now let us see the working principle of MOSFET. So the working of MOSFET depends upon the MOS capacitor. The MOS capacitor is the main part of MOSFET. The semiconductor surface at the below oxide layer, which is located between source and drain terminals, it can be inverted from P-type to N-type by applying positive or negative gate voltages. When we apply positive gate voltage, the holes present under the oxide layer with a repulsive force and the holes are pushed downward with the substrate, and the depletion region populated by the bound negative charges which are associated with acceptor atoms. The electron rich channel is formed now. The positive gate voltage also attracts electrons from the N plus source and drain region into the channel. Now if a voltage is applied between the drain and source, the current flows freely between source and drain and the gate voltage controls the electron in the channel. If we apply negative voltage, a whole channel will be formed under the oxide layer. So this is about the working principle of MOSFET. Now here is a block diagram of MOSFET. Now let us see what P-channel MOSFET is about or its work. In P-channel MOSFET, the drain and source are heavily doped P plus region. Here this Drain and source are heavily doped P plus region as shown in the figure, P plus and P plus, and the substrate of the body. This one is N-type. So in p-channel MOSFET, the flow of current is due to positively charged holes. The name itself gives, or and the name itself says that p-channel MOSFET. It is because the flow of current is due to holes which is positively charged. It is called p-channel MOSFET. This is the diagram, source, gate, and the channel region, which is in p-channel. In p-channel, MOSFET, this channel between source and drain is p-channel, so it is known as p-channel MOSFET also. Now let us see the next, that is n-channel MOSFET. Here it is the reverse case of p-channel MOSFET, because in n-channel MOSFET the drain and source are heavily doped N plus region, and the substrate or the body is p-type. So we can relate that p-n, we can understand that p-channel MOSFET and n-channel MOSFET are opposite, and in n-channel MOSFET there is n-channel between the source and drain, and the flow of current is due to negatively charged holes. That is why the name is given n-channel MOSFET, since the flow of current is electron which is negatively charged. So this is about p-type, and this is about p-channel and n-channel MOSFET. So let us see what next is. This is a diagram of n-channel MOSFET. Now, as we have studied the history, introduction, types, and other about the MOSFET, let us see where it is applicable in day-to-day life. So I have listed out some of the points where it is applicable. It is used in some amplifying circuits. It is used in chopper circuits. MOSFET can also be used as a high-frequency amplifier. It can be used in voltage regulator circuits. It can be used in DC relay, in electronic, and in digital circuits. Besides these, MOSFET are also used in many other fields, but these are few points that I have noted. So this is all about MOSFET, its working history, and its applications in day-to-day life. Thank you so much. Thank you.